In this problem, we want to use implicit differentiation to find the derivative of this function. Well, the function is not explicitly solved for, though, because we have a y cubed right here and we have a y cubed right there inside the natural log. So in order to differentiate this, we're going to use implicit differentiation. And that is where you take the derivative of both sides instead of first solving for y and then taking the derivative. So we have the derivative of the whole left side, that's a natural log, there we go, equals the derivative of the right side, the derivative of 4. That is right there. So on the left, for the first term, for the derivative of 4x to the 5th times y cubed, this is 4x to the 5th times y cubed. There is a product between these two variables, so we're going to have to use the product rule to differentiate that right there. And for simplicity, I'm going to group the 4 and the x to the 5th together as my first factor. So by the product rule, the derivative of this term is the first factor, which is 4x to the 5th, times the derivative of y cubed. Remember, y is a function of x, so by the chain rule, the derivative of y cubed is 3y squared times the derivative of y, so times dy dx, plus the second factor is y cubed, times the derivative of 4x to the 5th would be 20x to the 4th. So all of that is the product rule for the derivative of that term right there. Then we want to differentiate the natural log of x times y cubed. Again, we're going to use the chain rule because we have the natural log of a function. The derivative of the natural log is 1 over the inside function by the chain rule, xy cubed, times the derivative of xy cubed. So now I'm going to, let's do a different color here. That's the inside function chain rule, and now I'm going to differentiate x times y cubed by the chain rule here. So we have the first factor is x times the derivative of y cubed is 3y squared times dy dx, plus the second factor is y cubed times the derivative of x is 1. And all of that equals to the derivative of 4, which is a constant by itself. So that derivative is 0. Okay, now we need to solve for dy dx, and we have one dy dx right there and another one right there. So what we're going to need to do is expand and simplify and get all the terms with the dy dx on one side and everything else on the other side. So for this first term, let's simplify as we go. We can multiply the 4 and the 3 to get 12, x to the 5th y squared times the dy dx, which we treat like its own little factor there. This term has no dy dx's, so I'm actually going to move it over to the right side by subtracting it from both sides. So I'll leave it for in just a moment. And then over here, let's go ahead and distribute this over both of those terms because we do need to get the term with dy dx separated from this y cubed term. So in distributing, I'll go ahead and write it all out. We'll have 1 over xy cubed times this first term is x times 3 times y squared times dy dx, plus this times y cubed, so plus 1 over xy cubed times the y cubed right there when we distribute, equals to 0 minus that whole term, so negative, and let's rearrange it here and write it as 20x to the 4th y cubed. Okay, now we can simplify these two. Lots of things cancel here. We have x divided by x. Y squared over y cubed, 2 of the y's cancel. And then right here, these y cubes cancel. So cleaning this up, we have 12x to the 5th y squared times dy dx. Let's see, in this next term, I have plus 3 over y. Right there, 3 over that y times this dy dx. And this term actually has no dy dx's. In fact, all that's left is 1 over x. So we're going to subtract 1 over x from both sides and put it over on the right. Okay, now we have the dy dx's on one side, the two terms with the dy dx on one side, and everything else on the other. So in order to get that dy dx all by itself, the trick is to factor it out from the left side. So when we do, in this first term, we're left with 12x to the fifth y squared plus 3 over y is equal to all of this, negative 20 x to the fourth y cubed minus 1 over x. And now we're almost done. We just need to get dy dx all by itself, and we can do that by multiplying or dividing both sides by this whole giant factor right there. So we have dy dx equals everything over on the right goes into the numerator, negative 20 x to the fourth y cubed minus 1 over x, all over 12x to the fifth y squared plus 3 over y. Now it is a complex fraction, so this is a perfectly acceptable answer. If you want to clean it up, you could multiply the entire thing by this x and that y, so by xy over xy, and then FOIL it out over the numerator, not FOIL, but distribute it over the numerator and over the denominator. And then when you multiply this 1 over x times xy, the x's cancel, and for the 3 over y times xy, the y's cancel. Just eliminates the complex fraction, but it would have been a perfectly acceptable answer before as well.